Hello, everybody, and welcome to another session of Me Programming Daily. I hope everybody had a great weekend. I certainly did, but happy to be back to Haskell and Docker. Today on the agenda, drakon render again. Did I say Docker? I meant drakon. Now, today on the agenda, is balanced graphs for the drakon renderer, and maybe you noticed after the last session off camera, I added dependence to this markdown, so it indicates what are the dependents of every icon provided in the input. And that highlights an issue that I already have in the list of issues. Those valence points that are injected automatically do not have any dependence, and nothing also has them as dependents, meaning that if we wanted to position them using the already implemented algorithm of laying out icons, that wouldn't work. I decided, though, that before we fix that issue, we try to generate slightly more involved diagrams just to see how valence points would be injected in more complicated scenarios. And only then, when we prove that more complicated scenarios are fine, only then we can proceed, I think it would be sensible, to linking those valence points to their parents and to their dependents. Now, having said that, let's dive into the code. I see I'm already in the code view. So today I'll be working on this issue, create a slightly more sophisticated diagram requiring two valence points in one path. So right now we only have one valence point in one path. Let's see what happens when we need to inject two. Will the algorithm handle it? And if not, what would break? Let me just check if my OBS is fine. It's looking good. So let's check the branch. So the only change that will be required for this simple diagram 2 is that icon 3, which is, I can actually show it to you here in the README. Choice 1 will not go directly to the end. It will go to another action icon. Choice 2. Oh, maybe not choice 2. Let's give it a different name. Let's call it action 1. Action 1. Action 2. Now, let's shift all the names down. So this will take name 4, and the icon end will take name 5. So this will lead to 5. This will lead to 4 correctly. And this question 2 will lead to icon 3, which is not changing, and to icon 5, which is the end. Now, let's modify the run script. Let's build it. I noticed there are some suggestions made by HLint Oh, and this is a good suggestion. Let's use if else. This is in line 272. In if. So what we want to see is the same. I'm not clicking up this yet. We want to see a very similar list of lists here, or a list of paths. The only difference is that there should be one more valent point injected here, also identified as 0. Meanwhile, this path should remain 1, 2, 3, 4, and 5, because we've just added one icon. Let's see if that is going to be the case. 1, 2, 3, 4, 5. 2 valent points identified as 0. This is looking good. So this proves that the algorithm behaves well for simple scenarios where we just add more than one valent point. Let's quickly add it and commit it. So this is good. I think we have enough time to tackle maybe one more. This is 125. I also created one more item, or one more issue, and that is to inject valent points in more than one path, just to see what happens. Right now, we only inject in them in one path. Here, path 2. And we don't actually need a review on this. I'm just going to go ahead and merge it straight away. And let's quickly create another branch. Which will be our foundation for issue 126. So what we want to do is to complicate the graph a little bit and have at least two branches in which we need to insert at least 2 valence points. So what does spring to mind let's quickly revise this. We could, well, first of all, let's create the JSON file for this. And in here, instead of going straight to the end in action 2, instead of going straight to the end here, well, that's not action 2, is it? Oh, here. I'm going to say it one more time. Instead of going straight to the end here, I'm going to first inject one more icon here on the main path. Let's take a sneak peek how this is rendered. Please remember, we are expecting the rendering to be correct. We're just using a layout algorithm that I feel could be optimized and improved, thanks to balancing the graph before we commence rendering or the process of laying out the icons. So what I'm thinking is, if we put a question icon here that goes straight to the end in the yes path and straight to the end in no path, and also inject one more icon here, that will require the yes path of the new question to have 2 valence points and the no path of the new icon to have 2 valence points. Okay, let's proceed carefully. So we're injecting, or adding action 3. And just like previously, we're just shifting the IDs down. Let's call end 600 just to make sure we have enough IDs. And this is going to 5 now. Yeah, this works. And this is no longer going to 5 because 5 doesn't exist. It will go to 6, which we're going to create just now. So 6 is going to be another question. And this time the question is going to be pretty straightforward. Let's call it question 2. And this was question, let's turn it into question 1. It will be identified by name 6. And I can't really add two 600s here because the dependence should be different. I'm not sure we validate for this, but I don't want to set a precedent. So let's create two new icons, 7 and 8. And now, because we have so many actions, we're going to give them names, descriptions that are corresponding to their names, so that it's easier to debug. So icon 3 becomes icon 1 becomes icon 3 because of its name. Action 2 becomes action 4. Action 3 becomes action 5. And now we need two actions here. Action 7, identified by 7, that goes to 600, which is the end. And action 8, identified by 8, that goes to 600. And now that we know how many icons we exactly have, I'm going to rename 600. Oh, no. Let's just leave it at 600. We might have to insert one more. Yeah, we will have to insert one more action here. But for now, let's run it. Let's see what happens. Okay, so what we have here is it's a good start. 1, 2, 3, 4, 5, 6. It looks like the dependents are looking correctly. In path 2, we have one valent point, which is injected where the 5 used to be. Oh, sorry, it was 600 used to be. That's good. So it means that we need to shift 600 once more by adding action 6 to the mix. Let's do that. So far, it's looking promising. Let's see if the graph got rendered. It did get rendered correctly, if you can see this. But we've only injected one valent point in each of these paths. We need ideally 2. So that should be easy to correct. Let's just modify this JSON. And we should add another action to here. That shifts those IDs by 1. Let's call it 7. And because we have so many actions and questions, I'm just also going to do the same thing with questions. I'm going to change their description to reflect their names. Question 2. One thing that was incorrect. Oh no, it was correct. That's 6. So let's make sure we're not making any silly mistakes. This stays, but let's move it all by 1. So 6 becomes 7. Seven becomes 8. Also, we don't even have a 6. So that's interesting. There is a 6. But I think we renamed it. Okay, so let's proceed very carefully here. Title 1 has one dependent, that's 2. This has 3 and 7. 3 is an action. That goes to 4. 4 goes to 5. 5 goes to 6. Action 6 goes to the end. 600. Question becomes 7. That goes to 8 and 9. That becomes 8. That becomes 8. And that goes to 600. And 9. 9. 600. Now, we know that 600 is a little bit too much for our case, so we'll just rename it 10. And let's check everything at the beginning. 1 goes to 2. 2 goes to 3 and 7. Let's park the 7 for a minute. 3 goes to 4. 4 goes to 5. 5 goes to 6. 6 goes to 600, which is now 10. Now we can unpause question 7. 7 goes to 8 and 9. Let's park 9 for a minute. 8 goes to 600, which becomes 10. And unpause 9. 9 goes to 600, which is 10 now. And end is 10. Okay, so this is the same diagram. Let's run it. Sorry, let's preview it. Oh, we have the same problem with MD not getting refreshed correctly. But we can sort of see what's happening here. So this is fine. 1, 2, 3, 4, 5, 6, 10. And let's trace the dependence. 1 goes to 2, 2 goes to 3 and 7. Let's park 7 for a minute. 3 goes to 4, 4 goes to 5, 5 goes to 6, 6 goes to 10, and 10. Perfect. So the first column is all right. Path number 2. 1 goes to 2, 2 goes to 7. So here we will be at 7. Yes. And then it goes to 8. Let's park 9 for a second. 8 goes to 10. Valent point, correct. And 10 is our last icon. This is correct. And now we need to unpause path containing icon 9. 1 goes to 2. 2 goes to 7. 7 goes to 9. 9 goes to 10. Valent point, end. Perfect. So it is not reflected yet. I'm not sure why. Oh yeah, now it is reflected. So yes, I'm pretty happy with this. Let's see if our old layout engine did a good job. It did. It injected 2 valent points here and here. Well, not valent points. It's just linked those 2 or 3 pieces correctly. It went from, you know what, let me just make it a bit larger. It went from action 8 to action 10 correctly. It went from action 9 to the end correctly. But the old version does not have the concept of valent points yet. Nevertheless, I'm pretty happy with this. It does work. So I think we're just going to wrap up the session for today. It's just going to be nice and short. And that will buy me some time to think about how we could start linking those valent points correctly. give them correct IDs, because we've injected 4 different valent points that probably deserve only 2 different IDs, because these 2 valent points are what stands between 8 and 10. Oh no, sorry. So we'll need 4 different IDs. Yeah. But we can figure this out a little bit later. Looking at one of our more complicated diagrams, for example, let's see this. Primitive diagram 1. I wonder if we could achieve something like... I wonder how the valent points would deal with a diagram like this. I'll create this issue for another session. So primitive diagram 1. In the meantime, let's not lose focus. This, I feel, perfectly resolves issue 1 to 6. Two points in each of the 2 paths. So let's do 2 things. One is let's PR this 1 to 6. We've made no code changes. So this can just be merged. And an issue for another session is going to be test the okay, and here is the diagram. Oh, sorry, wasn't supposed to be that. That's primitive. And the reason I want to test it with this primitive diagram is the fact that primitive diagram actually loops back. So by testing it, we will not only test how the valent points are injected, but primarily how the DC paths function works. Because something tells me that if we have a loop like this, when we generate the path, and that would be path number 2, path number 1 being just a straight line here. When we generate a DC path following this sort of trajectory, we could end up ordering the recursive function that generates the path to loop indefinitely, because there's just no terminating icon. So I have a feeling we'll have to change the DC paths function during the next session to stop when it already when it starts looping. but we can address it during the next session. For now, I'm pretty happy with the result. Let's just double check if this is all correctly on the main branch. Yeah, we're on main. Simple diagram 3. It looks correct. Okay. Right, so a short session today, but we resolved 2 issues. So this is a pretty good pace. I would like to thank you all very much for sticking with me today. And I'm very much looking forward to the next session, during which we will be testing the primitive diagram 1. And I'm expecting complications, and complications are almost always fun. Right. Having said that, I wish you all a fantastic day, and I'll see you next time. Bye.